In this example, we want to solve the rational inequality 1 over x minus 1 is less than or equal to 1. Remember, we graphed the function f of x equals 1 over x minus 1 previously, and now we want to know when this function y equals f of x is less than or equal to 1. To help us visualize this, we'll add the line y equals 1 to our graph, and we want to know when our function is below this. We saw and can see in our graph now that 1 over x minus 1 can change from it being less than 1 to it being bigger than 1, or vice versa, at the vertical asymptote and at the point when 1 over x minus 1 equals 1. So we need to find the x values at the vertical asymptote and at the point of equality. To find the vertical asymptote, we want to know when our denominator, x minus 1, equals 0. Now this is easy to solve by adding 1 to both sides, giving us x equals 1. And for finding the point of equality, we want to know when 1 over x minus 1 equals 1. If you'd like to see the steps of solving this done out, you can click the link to the left now. Solving the equation 1 over x minus 1 equals 1, we find the solution x equals 2. So now we can break our x number line, or axis, into 3 regions. Everything before x equals 1, everything between x equals 1 and x equals 2, and everything after x equals 2. Checking the region where x is less than 1, we can pick x equals 0. Using x equals 0, we get that our function 1 over x minus 1 evaluated at 0 is 1 over 0 minus 1, which is just negative 1, which is most importantly less than 1. This means that x equals 0 is a solution, and so every value of x where x is less than 1 is a solution as well. For the region where x is between 1 and 2, we can pick x to be 1.5. For x equals 1.5, our function evaluated at 1.5 is 1 over 1.5 minus 1, which is 1 over 0.5, which is 2. This is bigger than 1, which means that x equals 1.5 is not a solution, and so every value of x between 1 and 2 is not a solution as well. Finally, for the region x bigger than 2, we can pick x equals 3. At x equals 3, our function at 3 is 1 over 3 minus 1, which is 1 over 2, or a half. This is less than 1, which means that x equals 3 is a solution to our inequality. And since x equals 3 is a solution to our inequality, every value of x bigger than 2 is a solution to our inequality as well. So we can conclude that the solutions to 1 over x minus 1 less than or equal to 1 are all the points from negative infinity to 1, along with all the values from 2 off to infinity. Notice here that 1 is not included in our solution set, because our inequality is undefined at x equals 1, since the denominator is 0.